In this video, we're going to be looking at this problem, valid square. So we're given the x, y coordinates of 4 points, P1, P2, P3, and P4. Also, the points are given in any arbitrary order. And we want to return true if and only if the 4 points construct a square. So let's take a look at the examples. So if you plot 0, 0, 1, 1, 1, 0, and 0, 1, it does construct a square, so we return true. But if you plot 0, 0, 1, 1, 1, 0, and 0, 12, it does not construct a square, so we return false. So this is more of a math problem than it is coding, but regardless, this is a very common interview problem. Let's take a look at the geometry. So try plotting different examples of 4 random points constructing a square. So you can have something typical like this, where the sides of the square are parallel to the x and y axes. But then there's a lot of different orientations, like this for example, where the square is essentially diagonal. Once you've tried enough examples, it should become pretty clear that it's useful to have these points labeled in a particular order. So in this case, you would have P1, P2, P3, and P4. Because now you can reason about whether this is a valid square. So we know that P1, P2 needs to be the same length as P3, P4, P1, P3, and P2, P4. So when all the sides are the same length, the shape is either a square or a rhombus. So to rule out that it's not a rhombus, we can check that the diagonals are the same length. So P1, P4 is equal to P2, P3. And then the only other edge case is that all 4 points are actually the same point, in which case the shape is just a point. So we want to check that the area is also greater than 0. So P1, P2 times P1, P3 should be greater than 0. Now the question is, well, how do we determine the order of the points are like this? Well, the first observation is that they're all ordered by their x coordinate, like this. So in the case of a tie, then we just want to order by their y coordinate. So essentially we want to sort the coordinates by their x coordinate and then their y coordinates. Let's summarize what we've just learned. So first, a valid square has the following properties. So all sides have the equal length. Its diagonals have equal length. And its area is greater than 0. So then the pseudocode will look something like this. So first we sort the points by their x coordinate, then by their y coordinate. Then we want to check that the sides have equal length. And this is done by checking that P1, P2 is equal to P3, P4, which is equal to P1, P3, which is equal to P2, P4. We want to check that the diagonals have the same length. So P2, P3 is equal to P1, P4. And then lastly, we want to check that the area is greater than 0. So P1, P2 times P1, P3 is greater than 0. So if all these checks pass, then we have a valid square, so we return true. Otherwise, we return false. The time is 01. So keep in mind, even though sorting is n log n here is a constant, which is 4. Space is 01 since we're not using any additional space. Let's implement this in Java. We're given the points as integer arrays. So let's create a 2D array called points that holds all 4 of the points. This is so that we can sort it later on. Points 0 would equal to P1. 1 equals to P2. Points 2 is equal to P3. Points 3 is equal to P4. Then we're going to do arrays.sort on the points. I'm going to pass in a lambda function here. It's going to be the comparator. There's a bunch of ways that you can do this, but I'm going to first check if their x coordinate is the same. Then we're going to compare them by their y coordinate. Otherwise, we're going to compare them by their x-coordinate. So now let's create a helper function to compute the distance between any 2 points, p1, p2. Recall from math class that the distance is computed as the square root of x1 minus x2 squared plus y1 minus y2 squared. Now let's compute the length of the sides. So keep in mind, since this is a zero indexed array, we're going to call them p0, p1 instead of p1, p2, and etc. Let's also compute the length of the diagonals. So first we're going to check that p0, p1 is equal to p2, p3, and p0, p2 is equal to p1, p3, and p0, p1 is equal to p0, p2. So this is going to check that all the sides have the same length. We're also going to check that p0, p3 is equal to p1, p2. So this checks that the diagonals are the same length. And then lastly, we're going to make that area is greater than 0 check. So p0, p1 times p0, p2 is greater than 0. Okay, let's run this. Okay, cool. You'll see that it does indeed pass. And that's how you solve the problem of valid square.